All right, we are going to continue on with special triangles today, but today we're going to look at 30, 60, 90. So these triangles look something like this. So we generally have, wow, that probably doesn't look like it at all, but this would be a 60, this would be a 30-degree angle, and then of course it's a right triangle, so we have a 90. But where did this start? So let's back this up just a little bit and figure out how we got there. So let's start by looking at an equilateral triangle. So if I draw an equilateral triangle, okay, if this will let me draw an equilateral triangle. Oh man, come on. Like this. Ta-da! Okay, so this is an equilateral triangle. Equilateral triangle means a few things. First of all, it means that all the sides are the same, okay? It also means that every angle is 60 degrees. 60 degrees. So we are going to say that this has all the sides that equal 2. They're all 2 units. All right, and here's our 60. Our 60 is what we're aiming for today. Remember, we're looking at 60, 30, 90s. So here's what I'm going to do. I'm going to cut this thing in half. I'm going to cut this triangle right down the middle. And if we cut this triangle in half, then what happens? This whole side is gone. We're going to make this just disappear, okay? And if I do that, then what do I now know? What do I know about that? What is the length of my bottom side? What is the base now that I've cut this in half? This base is going to be 1 because it originally was 2 and now it's 1. What do I now know about this angle right here? What does this angle have to be? It used to be 60. I cut it in half. So now it's going to be 30. So now I have this triangle that looks just like what I originally drew over here. I have a 60 and a 60, a 30 and a 30. And I got it by taking an equilateral triangle and cutting it in half. Now we chose 2 to be the radius, kind of arbitrarily, but that's okay. It doesn't matter, right? The ratio never changes. So that's where this came from. And what it lands me is this triangle. So if I focus on this triangle, I now have a 60, 30, and it's a right triangle, so that's 90. We said this was 2. We said the base was 1. So now what I would like to know is what is this height? So we're going to use Pythagorean theorem to figure that out. So we know that a squared plus b squared equals c squared. And if that's the case, a squared plus b squared equals c squared. And I know that a is 1, so a squared. I'm looking for b squared. And I have c, it's 2, so 2 squared. So that gives me 1 plus b squared equals 4. And now I'm going to rearrange for b. So b squared equals 3, right, if I move my 1. And now I need to take the square root of both sides. So if I do that, now I have b equals the square root of 3. Okay, so let's write this maybe a little bit nicer. So here is my special triangle. And I've now determined that I have a 60 degree, a 30 degree, a base of 1, a hypotenuse of 2, and a height of root 3. All right, and the way we did that, if you want to look at the progression we just worked through one more time, is we took an equilateral triangle. We said that each side was 2. We cut it in half. That gave us a base of 1, a hypotenuse of 2, and left us to figure out our height. We knew that that top angle was now 30 because it had been 60 because it was equilateral and we cut it in half, so we had 60, 30. We used Pythagorean theorem to find our height, which we now know is root 3. So here's where we've landed. Now there's just one final step. So here's the deal. We don't actually like having a hypotenuse of 2. What we would really like is a hypotenuse of 1. Okay, so we're going to take our same triangle, and I need this hypotenuse to be 1. So how am I going to make that happen? How do I take my 2 and get it to a 1? Well, I'm going to divide it in half. I'm going to divide it in half. So if I divide one side in half, I need to divide all the sides in half. So this actually gives me a hypotenuse of 1, a base of half, and a height of root 3 over 2. So don't forget, we still have our 60 here, and we have our 30-degree angle, and of course our right triangle. So just to recap, the way we landed at this final special triangle was a little bit of a process. So here's how this went down. We started over here with an equilateral triangle that each had a side of 2. And then we knew that that was 60 and 30. We cut that in half. We removed half of it, and that gave us our 60, 30 and our sides of 1 and 2, because we cut the 2 on the bottom in half and got a 1. To find this side, we used Pythagorean theorem, and we arrived at root 3. Then we decided our hypotenuse actually needs to be a length of 1, so we cut everything in half to get us a 1, a half, and a root 3. So we're going to see both of these two quite often. So I'm going to draw this one more time for you so it looks really nice and pretty. Quite often, it depends on what you're doing, but sometimes you use the 1, 2, root 3. That is useful. The smaller version of that with the 1, the half, and the root 3 over 2 is going to be very important next year in grade 12 math. So these two things are the same, right? They are both proportional. They're the same. They're going to help us with trig, and I guess what I really need you to know right now is that they both exist, and they're the exact same thing. They're just proportional. There's just a smaller version of each other. And I want you to know the theory of where they came from. Now, let's take this a step further. Remember, we're really putting this in a graph, right? So if we put this on a graph, it looks like this. And our 60, the way it's drawn right now, our 60 is right here in the middle. So if I wanted to kind of keep moving with this, I would draw my angle in standard position, and it would look like this. And if I wanted to know the coordinate here, the coordinate of this would be what? What's my x value? My x is 1, and my height is root 3. So if I wanted to figure out, let's say, the sine of 60 degrees, I know that the opposite is root 3, and the hypotenuse is 2. And sure enough, you should be able to put this in your calculator. That being said, you can do the same for cosine of 60 and the tangent of 60 degrees. And if we keep going with that, then we're like, okay, cosine is adjacent over hypotenuse, which we know is y over radius, which is now, what's that, root 3 over 2. Wait a second. Back the train up. Adjacent is 1 over 2. So the cosine of 60 is half, 0.5. And then if we do tangent, we know tangent is opposite over adjacent, which is y over x, which is going to be root 3 over 1, right? Okay, now, here's the real kicker. This is all for 60, right? This is how we find the sine of 60 and the cosine of 60 and the cosine, or the tangent of 60. What if we want to do 30? We're literally going to pick up our triangle. We're going to pick up our triangle. I wish I knew how to do that. Oh, I think I just didn't know how to do that. We're going to pick up our triangle. Ah! And we are going to, watch this. Watch me blow your mind. We are going to turn it over. How do you turn this over? Okay, so I can't make it flip the right way, but hang with me for a second. If I draw us a new graph, okay? Actually, let me draw that in red. If I draw a new graph, we're going to take the same triangle, but we're going to take this 30 and we're going to put the 30 in the corner. So if we do that, the triangle itself doesn't change, right? It's just going to be a little bit lower. So let me highlight this so you can really see what I'm doing here. I'm going to take the blue side, okay, had the 60, and then let's make the hypotenuse, we'll make the hypotenuse yellow, and then we'll make the brown side root 3. Okay, so that means my hypotenuse is still my hypotenuse. So this is still yellow, okay? And then that means that this is my 30, right? This is now 30 degrees, which means this has to be 60 degrees. And so this short side, what was my base, this was my x, and that's now going to be the y. So this is now the blue side. This is now the y. And the brown side is now laying down here. So I picked it up and I turned it over. And then, so my lengths don't change on this, right? Like this is now root 3, this is 2, and this is 1. So we just picked it up and we just turned it over, and then we can keep going. So now we know that the sine of 30 is still opposite over hypotenuse, which is still y over radius. I said that wrong up here, didn't I? This was supposed to be x. Which is now 1 over 2. And the cosine of 30, which was adjacent over hypotenuse, is now x over radius, which is root 3 over 2. Okay, see how this all works? Then, just like we did with the 45, 90, we can move all of these into different quadrants, right? Because it's all about reference angle. So if we do that, I'm struggling here. Okay. If we do that, let me slide. Let me erase. Okay. So if we do that, then we can move, remember our 60-degree triangle can come over here, right? And this is still 2, this is still root 3, but now our 1 is -1, okay? So this is still a reference angle of 60, which means what's the actual angle here? 120, right? So the sine of 120 is going to be the same as the sine of 60. And then the cosine of 60, the cosine of 120, the cosine of 120 is going to be adjacent, which is -1 over 2. So it's got the same value as 60, except it's negative because the x has changed directions, right? Because we're in quadrant 2. Same goes for quadrant 3 and quadrant 4. Your x and your y's are going to change from positive to negative as you move around. But let's be really clear with this. I'm going to come over here. With 60, we have 60, 120, quadrant 3 has an angle of 180 plus 60, so 240. And then over here in quadrant 4 is 300. So all of these angles will share the same ratios because they all have a reference angle of 60. And then down here, let me make this red so you can see that a little bit better. There's your axis. Okay, and then 30, let's go back through our angles that are associated with a reference angle of 30. So that's going to be 30 for quadrant 1. Quadrant 2 is 150, right? A reference angle of 30 is 150 in quadrant 2. And a reference angle of 30 in quadrant 3 is 210. And a reference angle of 30 in quadrant 4 is 330. Okay, so if you were going to screenshot anything, let it be this. Actually, yeah, let it be this. So here you've got your reference angles associated with 60, your angles that are associated with 30, and here you have your special triangle for 30 and your special triangle for 60. These are the same triangles, they've just been turned over. Okay, that's it. Great job.